How can you turn a complex document such as this PDF that contains text, different tables, and images into something that your AI applications can understand and use as knowledge? In this video, I'm going to show you a complete processing pipeline that takes documents such as this one that you're seeing right now and converts it into text that your LLM or AI applications can understand. Hey everyone, my name is Vinelin, and in this video we're going to build a complete document processing pipeline that takes raw documents such as a PDF file and convert them into text that your LLM or AI application can understand. We are only going to be using local models for OCR, layout detection, image understanding, and then LLMs to do the chunking and contextual enrichment of the chunks that we're going to prepare and test with a sample RAG application. Let's get started. Our document processing pipeline is going to ask for a document as an input and will contain three different stages. The first one is going to be the parsing. Here we're going to be using a Docling in order to do the heavy work for us. This will contain OCR model, convert the different pages into images, and then for each image found within the document, we are also going to use a description of the image and replace that description within the resulting markdown that we're going to be passing to our chunking algorithm. Our chunking algorithm is going to be a simple hybrid between LLM chunking and understanding the structure of the markdown. Finally, we're going to be going to the contextual enrichment, which is very much inspired by the contextual retrieval blog post by Anthropic and the same strategy presented by Microsoft. Here, we're going to add additional context to each chunk from the document and return this as a result of our pipeline. If you want to follow along, there is a complete text tutorial along with the source code that I'm going to show you throughout this video. This is available for ML Expert Pro subscribers and it is within the V2 preview bootcamp materials. Here within the build AI product section, create knowledge for your documents. And here you can find a complete explanation along with the link to the Google Colab notebook that I'm going to be using. So if you want to join the bootcamp on ML Expert Pro, please consider subscribing to it. Thank you. Docling is the library that we're going to be using in order to convert our documents into Markdown format. This library is created by IBM and is completely open source. They're also working pretty tightly with Hugging Face and are even building models for it, such as the Docling model and small Docling models as well. With this library, you can get OCR, for example, from Easy OCR, Tesseract, other providers as well. In our case, we're going to be using a Rapid OCR, which I found to be working quite well for digital documents from the type that I'm going to go throughout this tutorial. Also, another important thing about building with Docling and other libraries, in general, I don't use the integrations with other libraries. I prefer to get a final export, if you will, from this library, for example, a Markdown or JSON or something else, and then from there continue with building with my AI applications. So this is an approach that works quite well and separates the document processing pipeline from the building of the AI applications, if you will. The document that we're going to be using is going to be this NVIDIA's announcement for financial results for the fiscal 2025 year. I really like documents such as this one since it contains a lot of formatting, as you can see right here, a lot of numbers, percentages, years, etc. And it contains a lot of technical jargon since most of the OCR models can be quite bad with those. And in this case, we also have a lot of tables that are not so easily representable or understandable by different models. We have some non-standard formatting for the headers here, as you can see, and a lot of different columns and layouts for the tables themselves. Before starting with the code, I just wanted to mention that cloud-based solutions for document processing, OCR, etc. are still far better compared to what we have as open source documentation or tooling. So if you want to build really a complete system that needs to handle a lot of load and you're striving for very good accuracy, probably your best bet would be to go for a cloud provider such as, for example, Google Cloud Vision, Ollama Parse, or other alternatives. In this case, I just wanted to let you know that open source models and open source tooling can be also quite good if you're working with at least well formatted documents. So this is the notebook that we're going to go through, and it is running into my local VS Code instance. Here you can see that we have a lot of imports that we're going to need for the Docling. And the important thing here is to download the PDF file, which is going to be available from my Google Drive. So the first thing that we're going to do for the Docling library or initialization is to create this document converter. This one takes as an input format options, and for a PDF, we're going to be passing in these pipeline options. Within these options, the first thing that I'm passing in here is that I want the Docling pipeline to generate a set of images that are going to correspond for each page that I have within the document. And their scale, I want to be 1-to-1 with the document page size. Also, I want the Docling pipeline to do the OCR for us and also describe the images themselves and convert all descriptions into text, of course. So another important thing that I've already mentioned is that I want this to be using a rapid OCR options. So we're going to be using a rapid OCR provider for the OCR, and then we're going to be using small VLM or small visual language model. And in this case, this is going to describe the images, and it is only 256 million of parameters, and this should work quite well on your local instance. All of this is working entirely locally, and if you have a GPU acceleration and CUDA properly installed, you will probably get a lot better performance compared to what I got on my M3 Pro machine. So after you have created the converter, I'm going to get a document path to the document itself. This is the same document that I've shown you just a while ago. And in order to get the conversion of this into from the document path, you see that I'm getting .convert, and this will give you a result. Within this result, I'm going to get the document result, which is going to be essentially the Docling document that we're going to get. And you see here that this took me roughly half a minute or even more, a minute and 10 seconds. This again will be much faster if you're doing a lot of more documents or you have CUDA properly optimized. So this is the document itself. It contains 10 different pages, and the first thing that you see here is that we have this placeholder for the image. So even though if you are passing in do describe image, the model itself doesn't automatically replace the images with the descriptions that the small VLM model provides. Other than that, this is the Markdown that you're going to get, and this is quite a long Markdown since we have 10 different pages for the document. What you see right here is that you have also tables, and for those of you that have looked through the document, you see the first error here. This is not what we've seen within the table itself. I'm going to do a visual inspection in a bit and show you what is happening. So within the visual inspection is something that I always do when I work with documents. So in this case, you can go through these parts here, check a bit of the numbers, check the title, for example, record full year revenue. Yeah, this looks quite all right. I mean, this OCR for an open source model or a set of models is quite good. Also, of course, this document is very nicely formatted. And when we come here to the table, you see that this gap is actually for each column right here. And you can also imagine that this will trip your LM if it is going through the table columns right here, and essentially saying that each header is this gap text. Another important thing here is that if you are usually doing some visual inspection, you probably notice that the column headers are actually these values, but it is extremely hard for an OCR models to take a look at this. So this is just a side practical note. If you're using OCR model, you can probably pass the document markdown that you're getting along with the image of the page, for example, to a VLM, for example, Gemini 2, you can pass in the markdown along with the page image, and probably this will fix some of the formatting errors, at least that you get from the OCR models. So keep that in mind. Of course, the visual inspection should be a lot longer, or a lot cover a lot more documents compared to what we're seeing right here. So based on that, you can essentially create some feedback for the next iteration of your document processing pipeline and hopefully make it better. Okay, so after you're done with the visual inspection, we're going to have a look at what is happening with the image annotations. Within this document, the only image that we got was the NVIDIA logo, and this is the description that is coming from the pictures annotations. From this logo we got this. In this image we can see a logo and a text, and this is the small VLM 256M instruct. This is the model that provided this description. Not great, but in this case this should work quite alright. If you're having a lot more images, for example diagrams or charts, or even more complex images, you can probably try to hook up this to, for example, your local Ollama instance with something like Qwen 2.5 VL, and probably get a lot better results along with some tuning of your prompts, that is. Next, I'm going to continue by getting the annotations for all the images. Again, we have just a single image here, so we'll just get a single annotation. And next, I just want to replace these placeholders that we've seen here within the text, for example, this, with the annotation that the model has given us. And in order to do that, I'm going to be building this replace occurrences function. I want the image placeholder to be this, and then I just want to break the pages into different ones by adding a page break placeholder, and we'll do that because we want to process next the document page by page. So if I export the markdown of the document and pass in those will be essentially replaced after running with this, and this is the image placeholder, and this will be the page break placeholder. So after we got this text, I'm going to be calling the replace occurrences, and I'm going to be passing in again the image placeholder with the annotations that we have extracted for the images. And you see that within the response we have in this image, we can see a logo and a text. Okay, so this is now going to be the process document or parse document pipeline, or at least part of the pipeline that we got. And this will take a document path converter and then the number of pages that we want to process. This pretty much contains all of the code that I've shown you thus far, but it is wrapped within a function. And again, I'm going to be loading the document and run this with the number of pages. Since I want this to be a bit faster for us to go through, I'm going to go to just through the first 4 pages of the document. But this will be enough since it will contain a lot of tables, text, etc. So the first thing that I'm doing after that is to essentially check the number of, let's say, words, and roughly estimate the number of tokens that this document is going to give us. Since if we are building a RAG or a chatbot application, we want to know this information to make sure that the chunks that we're going to be building next are going to be fitting correctly within the context. There are a lot of strategies for chunking text for your RAG applications, and within the report evaluating chunking strategies for retrieval, the team of Chroma, which is a vector database, are essentially evaluating the different available strategies here. And pretty much what they found, or the TLDR of this blog post, is that clustering or LLM chunking are very good strategies that yield pretty much great results, no matter the domain that you're going to do the chunking with. And of course, you see a lot of implementations and strategies if you're using libraries such as LangChain, Llama Index, and others. And of course, the question, what is the best chunking strategies, always stand. But of course, there is no easy or one answer. And given said that, the LM and clustering chunks are pretty much the best that we got so far. The LM chunking strategy that we're going to be using is the one from the blog post that I've shown you, but I'm going to start by splitting the document into different headers, and this is how I'm going to do it. I'm going to split by new line and a header character in a Markdown format, and those chunks I'm going to be creating a start of chunk with the index right here, end of chunk, index right here. So if this is starting with this symbol, or we're going to be adding it back in so we get better results. Let me show you what we get from this chunking itself. So this is chunk 0, chunk 1, until we find the end and the next start of header within the Markdown, etc. So what we're going to be using here is a local LLM, in our case Gemma 3, that is going to tell us essentially after this chunk, or after this chunk, split the document, since this is a good place for this document to be split in. So this will be essentially the chunking strategy that we are going to be using. And this is the code that I'm going to be using for it. I'm going to be using the latest quantized aware trained model from Google DeepMind. This is an official release. Of course, you're free to use any other model that you like, but I'm going to be using the Gemma 3 12 billion parameter model with these parameters. And I'm going to build this very simple call model helper function, which essentially is going to give or get the prompt and give us a response. I'm also increasing the context window, since some of the chunks might be even larger. So this is the way that I'm going to be building the prompt. Your assistant specialized in splitting text into semantically consistent sections. The text has been divided into chunks, each marked with start X and end X tags, where X is the chunk number. And what I want essentially is to give me your response in the form split after. Oh, I have a typo here. Let me remove that. And based on this, I want to give the document text and I respond only with the IDs of the chunks where you believe a split should occur. You must respond with at least one split. So no matter the document, I just want one split at least. Okay, so this of course assumes that you're passing in somewhat of a long document. And when I format this with the document text, I get the complete prompt. And if I call the Gemma model, again, if you are calling this model multiple times, this will be much faster. I got this response for our document. And then I have this helper function, split text by LLM suggestions, where I get the chunked text and the LLM response. And this will essentially go through the steps of understanding the chunks and give us the splits. So you see that the first chunk that we got, and yeah, we got 3 different chunks since we have 2 split points. And here you see that we have the first chunk in this image, etc. This is including this next header and the table itself. The next chunk begins with Outlook, NVIDIA's Outlook for the first quarter, etc., etc. What is nice about this approach is that you can essentially tell the LLM that you want, for example, tables to be never splitted, or for example, lists to be never splitted, etc. And this will probably be very much domain specific. So I really like this approach, and it is also quite simple that you expect the output to be just a list of numbers essentially, but not the complete text, which will slow down things even further. The contextual enrichment part comes from this blog post introducing contextual retrieval by Anthropic. I also found the same ideas presented by the team at Microsoft, and here we are pretty much seeing a way to add additional context to a given document to an LM. And in order to do that, we are going to be presenting the LM with the document text as a whole and then the specific chunk. Here you see a chunk before contextual enrichment, how I call it, and then with the contextual enrichment. And also this is the document prompt that they're using is a bit different, and I'm going to show you how you can do that. So this is our prompt. It's a bit more, let's say, specific. I want just 2-3 concise sentences that situate this chunk within the broader document, identify the main topic or concept discussed in the chunk, etc. So here is the document, here is the chunk, and then I want the response to be just the context itself. And I'm running the 4 different chunks through the local Ollama instance with Gemma 3. And then, for example, this is a context that we're receiving, for example, for the first chunk. These are only the contexts. The chunk itself is here. And then for the final chunks that we're going to be creating, I'm going to be appending this context chunk or chunk context, and then the chunk itself. And this will be a sample. For example, for the first chunk, along with this and the chunk itself. So after we got the enriched chunks, we can use them into a very simple rack, such as this one. And this is essentially an implementation using sklearn for a retrieval that is using TF-IDF vectorizer. And again, it's going to be pretty simple. If you want to try this within LangChain, Llama Index, or other retrievals, you can do that as well. And here, from this simple retriever, we're going to initialize an instance and pass in the number of chunks that we got. Those are the one that contain also the contextual enrichment. And here you see that I want the k of the number of contexts that I'm going to be receiving or chunks to be equal to 2. And here is the question that I'm passing to the retriever. What is Blackwell, which is essentially their new supercomputer of NVIDIA.is. And here you see the chunks that we're getting as a response. And the next chunk as well, the 2 chunks that we're passing in. And here is the prompt that we're going to be using for the rack. Very simple prompt. Use the context provided here to answer the question. Is context chunk contains a chunk of a larger document and its context provided within these tags. And here is the answer to the question. Here I have a very simple helper function to essentially wrap everything together. This is the retriever, getting the contexts from here and adding the prompt to the prompt or formatting it with the context and the query itself. And then finally using the prompt to call the Gemma 3 instance running on your Ollama. And here is the question, what is Blackwell? Blackwell is described as an amazing AI supercomputer. It's driving strong demand, and NVIDIA is successfully ramping up its production, achieving billions of dollars, etc. It's also mentioned as being used for reasoning AI, making models smarter and increasing compute for training and long thinking. Note that we still got the very large document, but the response here is very grounded or very specific to the document that we got, since Gemma 3 wasn't aware when training of this Blackwell architecture. And also here the model mentions that this is actually an NVIDIA Blackwell architecture. So I would say this response is quite good from Gemma 3. And what is the gaming revenue for fourth quarter? Here I wanted just a specific response, and the model gave me that from a Markdown table that it got, and the response is actually correct, $2.5 billion. So this is it for this video. we've built a very basic document processing pipeline that runs entirely locally, but can probably be a very good start to your exploration of how you can build your own for your own documents. Keep in mind that there is no perfect document processing pipeline, and you will probably need a lot of time in order to observe and go through the visual inspections of different documents that you're going to work with for your specific systems. Of course, you will probably need even better models as well, and for that you probably need cloud-based solutions. But in this example, we've used entirely local pipeline that works relatively well for very nicely formatted PDF files. Thanks for watching, guys. Please like, share, and subscribe. Remember that if you want to access the complete source code for this video, you need to subscribe to ML Expert Pro. I'm going to link the content on the tutorial within the video as well. Thank you for watching, and I'll see you in the next one. Bye.